Hi, in this video, we're going to talk about 10 details that your plans might be missing. My name's Chad Johnson. I'm with Truss Components of Washington. I've been in the truss industry for over 30 years, and I'm excited to talk to you about this topic in this video. Detail number one that your plans might be missing is the roof pitch. We see this a lot, and there are two ways that this can be a problem. One, the roof pitch might be missing altogether. There should be an overhead or a plan view that displays the pitch for each section of roof. In this case, we've called out a 612 on that plan view. Also, there should be a section cut or a cross section that shows the roof pitch. What we run into a lot of times on plans is either there's no pitch at all, or the pitch might be different from one view to another. The roof plan view might say 612, and then the cross section might say 412. So that's often the result of a designer, an architect, using boilerplate details. And if these don't line up, as a truss designer, we're not going to know which one to use. That's going to slow the project down. We're going to have to make a call or an assumption. Detail number two that is often missing on building plans is the height at the heel of the trusses. This is important because it determines how much space there will be for insulation, where the gutter line will be, and the type of fabrication at the truss end. So if it's a raised heel, we need to know what that height is going to be at that raised heel. If it's a standard heel, we need to know what cord size is expected, whether it's a 2x4 or a 2x6 cord. If that information isn't there, we're going to have to make an assumption or make a call. Another often missing detail, or one that is contradicted between different details in the plan, is what type of eave we're going to have, or the rafter or overhang. So an open soffit often just has a bare rafter that is resting on the bottom cord, so a standard heel. An enclosed soffit often has a cantilevered overhang, and that's where the bottom cord is extended out in order to get a finished soffit, something for that framer to attach the soffit material to. We need to know which one of these we're going to use to design the trusses, and if it is an open soffit on one part of the plans and a closed soffit on a different part of the plans, we're going to need to know which one of those is correct. Often missing detail number four is the overhang length. So this tells your truss designer how far to extend the truss or the top cord of the truss beyond the outside wall. The gutter for your building is going to sit at the end of that overhang. And so there are many different lengths that are typical. So to say typical overhang isn't specific enough. Anything from 12 inches to 24 inches we see very commonly, but we also see shorter lengths and longer lengths. So it's important to detail on your plans what you want that overhang length to be. That should be specified in a cross section and also on the overhead plan. You can see here where the overhang length would be indicated, and that's the length from the outside of the wall, as we mentioned, to the end of the truss where the gutter will be. Another thing to keep in consideration is that if there are two different pitches on the roof, for instance, a 612 and an 812 that are supposed to match at a point and have an even eave line, there are two different ways, three actually, that we can accomplish that. One is we can shorten the overhang on the steeper pitch in order to get it to be at the same height as the overhang on the shallower pitch. Another option is we can raise the heel on the steeper pitch so that we can run the overhang out just as far and not have it drop too low. And then the third option is a cantilevered overhang. When we cantilever the overhang, it doesn't matter what the pitch of the roof is, because that flat bottom cord extending out gets all of the eaves at the same height. Detail number six that your truss designer will need to know and is often missing on plans is what is the blocking detail at the bearing line or the truss eave. So there are multiple different ways that this can be handled. I've put up 3 examples here, but that is not all of the possibilities. One is a block that matches the depth of the top chord. So if you have a 2x4 top chord on that truss, for instance, then that would be a 2x4 member. It's typically tipped out to be perpendicular to the roof pitch. It makes a nice finished look on the outside. Those are often vented, holes drilled in them with screen over it in order to allow airflow but keep insects and other animals out. Another regular detail or another option for that is a block that is stood vertically at the outside of the bearing. And this is used to transfer shear from the roof down into the wall, usually using clips and nails and that sort of thing. Oftentimes on a set of plans, we'll see this detail in the architectural, we'll see this detail in the structural. If those are aligned ahead of time, it saves time and will help keep your project moving forward more quickly because we'll have less questions. The other option is a lot of times we get to a raised heel, usually in order to provide more room for insulation. Sometimes it's required to put a full depth block in there. Other times it's not. We just need to know what we're going to do, and that way we can estimate your project and design it correctly. Another detail, number 6 for us today, that is often missing on a set of blueprints is the dimensions for the beams. Quite often, we'll have dimensions for where, for instance, a column base is going to be located, but it doesn't indicate where the beam that might be supporting a porch roof is going to be in relation to that column base. Oftentimes, beams are dimensioned to the center line, but we're not given the information of what size the beam is going to be. If we don't have dimensions for where the trusses are going to land on the beams, essentially like out-to-out dimensions or a face-to-face dimension, for instance, a face of wall to face of beam dimension. If we don't have that information, then we don't know exactly how the truss is going to interact with that beam. Again, we're guessing or we're calling for information. Another bit of information that is often missing in reference to beams is what is their vertical location in either the roof system or the floor system. When we're talking about a beam, that means that it is held up above the typical bearing plate. If it's below, we're going to refer to it as a header. And the reason that this matters is if we have trusses on top of that wall system, they're going to interfere with that beam, or the beam's going to interfere with those trusses. Whereas if it's a header, the trusses will go over them. Either one is fine as long as we know ahead of time so we can accommodate for it. Number 8 on our common missing details is point loads from beams to trusses. It's not out of the ordinary for a roof truss or a floor truss to be carrying a load from a different part of the structure. In this example, we've got a second or third floor that is being carried by a girder truss on the roof below. So this beam here is carrying all of this floor system. That's going to impose a load on this girder with this hanger here. We need to know what that load is going to be. That load should be provided by the engineer of record on the project. We just need to know what that load is, and then we can accommodate it in our trusses. Number 9 on our list of missing details is truss to wall connection. A lot of times we'll have a truss for a lower roof, for instance, that is meeting a wall of an upper level. We need to know, are we tying into ledgers? Is there something in the wall? Are we using hangers? How is that truss going to be supported? And that's information that should be provided by the engineer of record. We'll match their details. Number 10 on our list, last but not least, is parapet heights. Oftentimes, especially with commercial buildings, think about your convenience store or your fast food restaurant. They have an exterior parapet, and that's just basically a screen that gives them space for signage, and it hides mechanical units on the roof. But we need to know, how high is that parapet going to be from the bearing wall or the bottom of the truss? So that information right there is often missing. If we don't have it, it can lead to redesigns and delays on the project. So it's great if that information is provided by the architect during the plan design process. I hope you've enjoyed watching this video and learned that if these 10 details are included in your set of plans, it's going to make for a smoother truss design process and a more on-time and accurate delivery from estimation all the way through to the trusses being on your site. If you'd like to learn more about roof trusses, you can take a look at this video here. If you'd like to learn about floor trusses, take a look at this video here. Thanks for watching.